So this video will show you the solutions on our long exam number 2 under load computation using NSCP 2015. So we have here our first problem. A school building will be constructed using steel as its structural members. Partitions will be made of precast wall that is 100 mm thick with a density of 1,700 kg per cubic meter. The internal height of each room is 2,700 mm. The floor slab is 130 mm thick. Ceilings will be made of 13 mm thick gypsum board. The rooms will be located on the second floor of the building. And all the concrete materials have a density of 2,350 kg per cubic meter. So neglect the weight coming from the door openings. So we have here the values for our beam 1 and beam 2 and also beam 3 and beam 4. And then sizes or yung ating dimensions for A, B, and C. So take note lang na random yung mga numbers na lumabas sa ating MVLE. For example, this one, W250 by 117. So naglagay lang ako ng range. For example, 90 to 200. So wag kayong magtaka kung hindi 117 yung lumabas sa exam nyo kasi hindi pare-parehas yung values na nilagay ko. And then if you check in our steel handbook, walang value ng 250 by 117. So this is intended for your exam only, okay? Hindi naman kailangan kasi dito yung mga geometrical properties ng ating steel sections because we are just computing for the loads. Ayan. So these sizes are just intended for your exam. Okay, so for question number 1, determine the total dead load in beam 1 and then dead load for beam 2. We will also determine the total load in beam 3 using the ASD. And then for number 4, the total load in beam 1 using LRFD. And then for the last item, determine the total load in beam 4 using the LRFD. So our first step here is to determine yung lahat ng loads na nag-a-act on this structure. So, nakalagay pala dito, neglect the weight coming from the door openings. So, kung makikita nyo dito sa partition wall, supposed to be tatanggalin natin yung area kung saan kung saan nakalocate yung ating door opening. But, we will neglect that. So, parang i-assume natin na buo siya. Kasi meron ding weight yung ating door, which is not given naman dito sa problem. So, neglect na lang natin and we will design this as whole partition wall. So, our first step here is to determine all the loads that is acting on our structural member. So, first step is yung ating self-weight. So, solve natin yung self-weight ng beam. In which yung ating beam 1 is equal to our beam 2. So, it is 117 kg per meter. Multiply lang natin siya sa 9.81 meter per second squared. And then, i-divide natin siya sa 1,000. Para maging kilonewton per meter. Therefore, we have 1.148 kilonewton per meter. And then for our beam 3 is equal to our beam 4. So, meron tayong 59 kg per meter multiplied by 9.81 meter per second squared. And then, yan. So, we have 0.579 kilonewton per meter. So, meron tayong self-weight ng beam. Next, proceed tayo sa mga partition wall. So, sa partition wall natin, so, tignan natin yung partition wall na nakapatong sa ating beam 1. So, this one, may partition yan, dyan. So, neglect natin yung door opening and then yung weight from the door itself. So, parang i-consider natin to as a whole. So, we have the density of the precast wall is 1,700 kg per cubic meter. So, i-multiply natin is yung thickness which is 0.1 meter and then yung internal height which is 2.7 meters. So, meron tayong kilogram per meter. So, multiply natin siya sa 9.81. And then, i-divide natin siya into 1,000 para meron tayong kilonewton per meter. So, parang ganito yan. So, we have here our beam. So, sabihin ko na lang rectangular. Although W shape yan. So, ito yung ating beam. So, may nakarest dyan na partition wall. Ayan. And meron siyang thickness na 100 millimeters. And yung internal height daw is from floor to ceiling. So, i-assume natin na yung internal height is from floor to ceiling, which is given as 2.7 meters. So, yung internal height natin, we assume that is also the height of our wall. So, 2.7 meters. So, paano natin makukuha yung uniform distributed load in kilonewton per meter? So, multiply lang natin yung density ng ating precast wall multiplied by the thickness and then the height para maging uniform distributed load yung mag-a-apply sa ating beam. So, we have now So, we have now 4.503 kilonewton per meter. Meron tayo sa beam 1. And for beam 2, so beam 2 natin, this one, may partition wall. And I assume, magkaparehas lang sila ng beam 1. Bakit? Because they have the same internal height, they have the same thickness. So, yung weight coming from the partition wall na nakapatong sa ating beam 2 is also equal to 4.503 kilonewton per meter. Okay? So, for beam 3 naman, so sa beam 3 tayo, this part, walang partition wall. Tama? So, walang partition wall na nakapatong dito sa beam 3. Kaya yung weight is 0 coming from the partition wall. Kasi nga walang partition wall. Okay? And then, for our beam 4, sa beam 4 natin, this one, may partition wall ulit tayo dyan. So, we have the same thickness, the same height, and the same density. So, yung weight coming from the partition wall in beam 4, resting in beam 4 is also equal to 4.503 kilonewton per meter. Okay? Next is the dead load coming from the floor slab. So, yung floor slab natin for beam 1. So, ang ating density for the slab is equal to 2,350 kilogram per cubic meter. And then, yung thickness daw ng slab is 130 millimeters. So, disclaimer lang ulit, random yung mga lumabas na thickness ng ating slab. So, 130 millimeters or 0.13 meters. And then, multiply natin yung tributary width. So, yung tributary width ng beam 1 is half of this portion. So, we have here 0.75 and then at this part which is 3 meters. So, 3.75 meters yung kanyang tributary width. So, 3.75 meters. Multiply natin siya ng 9.81 and then, i-divide natin siya by 1,000 para maging kilonewton per meter. So, we have So, we have 11.24 or 11.239. So, we have 11.239 kilonewton per meter. And then, for our beam 2, so, sa beam 2 natin, 2,350. Yung thickness. Yung tributary width niya, so, for beam 2, so, yung tributary width ng beam 2 is half of this one and then half of this one. So, 4.5 meters. So, 4.5 meters, multiply natin ng 9.81 and then divide it by 1,000. Therefore, we have 13.486. So we have 13.486 kilonewton per meter. And then for our beam 3, so 2350, 0.13. Tributary width ng beam 3 natin, this one. Ayan, so parehas sila ng beam 2. So we have 4.5 multiplied by 9.81 and then divide natin siya by 1,000. So it is same. So 13.486 kilonewton per meter. And then for our beam 4, so beam 4 we have 2350 multiplied by thickness and then yung tributary width ng beam 4 is this one lang. Kasi wala nang tuloy dito sa part na to. So, this one lang. So, we have 1.5 divided by 2. So, 0.75 multiplied by 9.81 and then divide natin by 1,000. So, it is equal to 2.248 kilonewton per meter. So, meron na tayong dead load coming from the floor slab. Next is the ceiling. Next dead load is yung ating ceiling. So, yung ceiling is made up of 13 mm thick gypsum board. So, opening your NSCP 2015. So, ang sabi ng NSCP natin, the dead load that is coming from a ceiling that is made up of gypsum board is equal to 0.008 kilopascal per millimeter thickness. So, i-multiply lang natin yung thickness ng ating gypsum board which is 13 mm. Yan. So, again, random lang yung paglabas ng 13 mm as the thickness. So, it is now equal to 0.104 kilopascal or kilonewton per square millimeter. So, anong gagawin natin dyan? I-multiply lang natin yung tributary width na nagre-rest in each beam. So, for beam 1, so we have 0.104 kilonewton per square millimeter. So, i-multiply natin yung tributary width. So, yung beam 1 natin is, tributary width niya is 3.75 meters. Therefore, we have 0.39 kilonewton per meter. And then for our beam 2, 104 kilonewton per square meter. Tributary width ng beam 2 is 4.5. Therefore, we have 0.468. So, we have 0.468 kilonewton per meter. And then for our beam 3, so 0.104 that is kilonewton per square meter. Multiply natin yung tributary which is also equal to 4.5 meters. So, it is equal to 0.468. And then for our beam 4, tributary width niya is 0.75. Multiplied by 0.75 meters. So, it is equal to 0.078. So, we have 0.078 kilonewton per meter. So, ito na yung ating dead load coming from the ceiling. So, na-compute na natin lahat ng dead load. So, next is we will compute for the live load na nag-act sa ating classroom and on the corridor. So, opening your NSCP para makita natin yung live load na nag-act sa ating classroom. So, yung ating classroom, this table. So, it is school, diba? And then yung classroom natin. So, the live load is equal to 1.9 kilopascal for the classroom, and for our hallway or yung corridor above ground floor, since it is located on the second floor, it is equal to 3.8 kilopascal. So take note of these two. Yung classroom natin, yung live load is 1.9 kilopascal, and dun yung hallway or yung corridor is equal to 3.8 kilopascal. So ang sabi ng NSCP, yung sa classroom, it is equal to 1.9 kilopascal, and then sa ating corridor or hallway is equal to 3.8 kilopascal. Ayan. So for our live load, LL, so for our beam 1, so beam 1 natin, so ito, so kukuha natin yung tributary area or yung tributary width ng ating beam 1. But take note of this one, dito sa part na to, ang load is coming from the corridor and this one coming from the classroom. So ang gagawin natin dyan, sa corridor we have 0.75, dito muna tayo sa ating corridor, we have 3.8 kilopascal or kilonewton per square meter. Ang i-multiply natin dyan is yung width coming from this part, we have 0.75 meters plus dito sa part na to. So we have here 1.9 kilopascal multiplied natin yung width which is 3 meters. So yung beam 1 natin is equal to 8.55 kilonewton per meter. 8.55. Then for our beam 2, sa beam 2 natin, nasa loob siya ng classroom. So yung tributary width natin is 4.5, and then we will be using the live load of the classroom which is 1.9 kilopascal. So we have here 1.9, multiply lang natin yung tributary width which is 4.5. So it is equal to 8.55 kilonewton per meter. And then for our beam 3, so beam 3, consider natin is yung weight of corridor or yung live load coming from the corridor. So 3.8 multiplied natin yung tributary width with each 4.5. So 3.8 times 4.5. So we have 17.1 kilonewton per meter. And then for our beam 4, so sa beam 4 natin, so ito yung consider yung tributary width which is 0.75. So we have 3.8 multiplied by 0.75. So we have 2.85 kilonewton per meter. So yan, kompleto na yung ating mga loads. Ang gagawin na lang natin is to substitute the values on the LRFDN sa ating ASD. So meron na tayo dito yung summarized na na-solve natin kanina for the dead load coming from the self-weight, partition, and the ceiling. And we also have the live load of each beam. So ang gagawin natin dito is to compute for the total dead load on each beam or acting on each beam. So B1 natin, we have 1.48. So i-add nyo lang yan, 1.148. 4.503, so floor slab 11.239, and for the ceiling 0.39. Therefore we have so sabihin natin meron tayong 17.28 kilonewton per meter na dead load. And then for our beam 2, so i-add nyo lang yan. So we have 1.148. So we have 19.605 kilonewton per meter. And then sa ating beam 3, have 14.533. And then for our beam 4, have 7.408 kilonewton per meter, and then we have kilonewton per meter. So what is our question number 1? So the question number 1, determine the total dead load in B1. So yung total dead load natin for beam 1 is equal to 17.28 kilonewton per meter. So ito na yung sagot natin for our question number 1. So for question number 2, determine the total dead load in beam 2. So the total dead load of beam 2 is 19.065. So this is the answer for question number 2. And then for question number 3, determine the total load in B3 using ASD. So gamitin daw natin yung ating ASD. So we only have the dead load and the live load. So dito, gamitin natin yung 203-9. So beam 3, so we have 14.533 plus yung live load that is acting on our beam 3, which is 17.1 kilonewton per meter. So it is equal to 31.633 kilonewton per meter. So ito na yung sagot natin for number 3. For question number 4, ang tinatanong niya is, determine the total load in beam 1 using the LRFD. So sa beam 1 naman daw using LRFD. So we have the dead load and the live load. So assume ko this one, 203-2 yung pinaka-maximum natin dito. So we have for beam 1, tama, beam 1. Yes, beam 1. So yung beam 1 natin, we have 1.2 multiplied by 17.28 plus 1.6 coming from the live load, which is 8.55. So it is equal to 34.416 kilonewton per meter. So this is now our answer for number 4. And then for our number 5, determine the total load in beam 4 using LRFD. So using LRFD, so ganun ulit, beam 4. So we have, dito na lang, so we have 1.2 multiplied by 7.408 plus 1.6 of the live load, which is 2.85. So we have 1.2 so it is equal to 13.45. So we have 13.45 kilonewton per meter. So ito na yung ating number 5. So, meron na tayo dito yung tabulated. So, meron na tayo dito yung summarized na na-solve natin kanina for the dead load coming from the self-weight, partition, and the ceiling. And we also have the live load of each beam. So, ang gagawin natin dito is to compute for the total dead load on each beam or acting on each beam. So B1 natin, we have 1.48. So, i-add nyo lang yan, 1.148, 4.503, sa floor slab, 11.239, and for the ceiling, 0.39. Therefore, we have so sa beam natin, meron tayong 17.28 kilonewton per meter na dead load. And then for our beam 2, so i-add nyo lang yun yan. So we have 1.148. So we have 19.605 kilonewton per meter. And then sa ating beam 3, have 14.533. And then for our beam 4, we have 2.248. And then for our beam 4, we have 7.408 kilonewton per meter, and then we have kilonewton per meter. So, ang tanong, so what is our question number 1? So, the question number 1, determine the total dead load in B1. So, yung total dead load natin for beam 1 is equal to 17.28 kilonewton per meter. So, ito na yung sagot natin for our question number 1. So, for question number 2, determine the total dead load in beam 2. So, the total dead load of beam 2 is 19.065. So, this is the answer for question number 2. And then, for question number 3, determine the total load in B3 using ASD. So, gamitin daw natin yung ating ASD. So, we only have the dead load and the live load. So, dito, gamitin natin yung 203-9. So, beam 3. So, we have 14.533 plus yung live load that is acting on our beam 3, which is 17.1 kilonewton per meter. So, it is equal to 31.633 kilonewton per meter. So, ito na yung sagot natin for number 3. For question number 4, tinatanong nyo is, determine the total load in beam 1 using the LRFD. So, sa beam 1 naman daw, using LRFD. So, we have the dead load and the live load. So, assume ko this one, 203-2, yung pinaka-maximum natin dito. So, we have for beam 1, tama, beam 1. Yes, beam 1. So, yung beam 1 natin, we have 1.2 multiplied by 17.28 plus 1.6 coming from the live load, which is 8.55. So, it is equal to 34.416 kilonewton per meter. So, this is now our answer for number 4. And then for our number 5, determine the total load in beam 4 using LRFD. So, using LRFD, so ganun ulit, beam 4. So, we have, dito na lang, so we have 1.2 multiplied by 7.408 plus 1.6 of the live load, which is 2.85. So, we have 1.2 so it is equal to 13.45. So, we have 13.45 kilonewton per meter. So, ito na yung ating number 5.